So for those of you who haven't seen the first video where I built this this transitional blend with just SolidWorks features, I'm going to do it with GeometryWorks 3D features in this video, but I just want to show you how it started. This was something that was posted on the SolidWorks forum, and somebody asked how you blend this out, and he had a good solution himself. Built it manually, kind of similar to the way that I'm going to show you. But he also showed that, you know, if you just apply a fillet to this sharp edge, because this edge has a curvature continuous point, it just sort of fades out into nothing and creates a singularity here. This geometry is pretty bad. It has really dense control points. And once you like try to offset or build stuff on top of this, you end up with all these sliver surfaces, and like geometry like this can cause a lot of headaches later on down the road. So I wouldn't build this way. So let's jump into this one. Here we have the reference surfaces set up, and I'm going to build this very similarly to what I did with native SolidWorks features, but using GW3D. They have a swept surface tool that is really nice, so we can use this the profile curve and this is the path. Those are kind of like interchangeable, and that gives me this surface. Now this is typically what you see in SolidWorks, and if we turn that on, you know, this looks pretty good. We can evaluate this with zebra stripes. Zebra stripes look really well behaved, so this is a nice smooth surface. One of the things that I really like and that I use all the time is this analyze surface geometry. You can see here that this is a really clean surface. This is the control point structure of the underlying surface. They're nicely distributed, they're evenly distributed, there's no wobbles, there's no peaks and valleys. And especially if you're doing like your initial primary surfaces that are highly aesthetical, this is a really nice tool to help you evaluate it. The result that you've created is good. Nice analysis tool. Use it all the time. So in the SolidWorks one, we used a 3D spline to build the edge from here to here, and in GW3D, we can just use a blend curve, and I love this tool. I love this tool. No sketches, no constraining, just say, we need two starting points and two curves, and so I want to go from, that's my starting curve, I want to be tangent to that, that's my ending point, and I want to be tangent to that, and here we have a curve in 3D. And I've already built this, so I know that in this case the row solution gives me the result that I want. I want a curve that follows this surface pretty closely and is really, really smooth, because this curve is going to drive my trim surfaces. So the smoother this is, the smoother my edges will be, that I'm going to trim back. So this looks really good, except that guy. So now I have this nice surface, or curve rather. And then they have this other feature, multi-blend. It's kind of similar to the boundary feature, it's just set up a little differently. And I've tested both of them. They do give different geometry and different results. Sometimes boundary is better, sometimes this one's better. I love having both of them, because if boundary fails, oftentimes this one works. And if this one fails, oftentimes boundary works. Don't know why, but having both of them typically allows me to get me where I need to be. And so I need to specify the tangency for the first three curves here. And because I've built these reference surfaces, I can use surfaces as my input. And so I can use this guy, that guy, and this guy to define my tangency. And we get a preview here. Turn that on. Yes. So now same thing. I've built this. I know that it follows this blend curve that I've created here. And I can quickly go in and see if I got a good result. And here again, you can see that these control points are behaved very, very nicely. They're very well distributed. There's no bumps, there's no ripples. And if I turn on a zebra map on this, that will show us the same result. We have a nice, smooth surface. Now, when I did this in SolidWorks, I built, or I sketched out a profile here on the front plane, and I sketched out a profile here on the right plane, and then I used a loft to create a tube to trim back the surfaces. Now that's all fine and great if you have planar surfaces. A lot of the times when you're surfacing and you're trying to build these transitional surfaces, these edges are not planar. And then, yes, you can use a 3D spline and try to do something that way, but it becomes much more cumbersome. Or you create like a separate plane that is perpendicular to this curve, you end up creating a lot of geometry. And this is a feature that I use all the time, the tube surface. It just automates this process of creating that helper surface to cut back my primary surfaces. So I just selected that, actually that selected the edge. I want to select the curve. There we go. And so now it's set to linear taper. You can set it to constant. There's a whole bunch of options that you have here, but this is a good one. So I'm going to start with 12, just like the other one, and then we're going to use 18. Now we can preview this. And so with just like 3 clicks, I've created the same geometry without the extra sketches required or reference geometry. All I need is an edge or a curve. Super helpful. Love it. So let's save that, and then we can go back and follow the exact same procedure, create a couple split lines, and we're going to use that with an intersection. This is my intersecting tool, and I want to split that guy and that guy. Yes. Now I can hide this tube, delete this guy, and that guy, and here we are with our 4-sided opening, just like we ended up in SolidWorks. But we have very few features. In order to create this 4-sided opening, I had to create this tube based on this blend curve, which was very easy to create. Split it, deleted it, and so now I can build the feature in between here. So same thing. In the SolidWorks video, I used sketches to bridge this and a style spline. But because here we have this wonderful blend curve, I don't have to sketch. I can just say I want to go from there to there, and I want to go from there to there, and I want to be curvature continuous. There we go. Just like that, I have a curvature continuous curve. And this is planar, but if it's not planar, you can do the same thing. You just pick a vertex and an edge, and it'll build the blend surface just like it did here in 3D. So let's build another one. Go from there to there, go from there to there, and yes, we want this curvature. And so now we have this nice 4-sided opening, and we can use the same boundary surface that we did in the just SolidWorks features. Select both edges, make these guys tangent. If you hear a little bit of growling, my dog is protesting because I'm not giving him enough attention. He's lying under my desk. And pick that curve. So now I have this all lined up. It's tangent, and same as with SolidWorks, we're going to make that 100% so that we have the most tangent influence from this primary surface number 1 and primary surface number 2. And here we have it. So with just a few, there's like an artifact. This sometimes happens. I don't know why that is. It's funny that it happens in a video. Sometimes I end up with these artifacts on my screen that just won't go away until I save and close. I'm going to leave it for now, maybe a forced rebuild. No. And then we can knit this together. And do that. Yes. So now we've knitted this together. I'm going to turn off my curves. And we can evaluate these edges to see if they're mathematically any good. So we got edge number 1. Calculate that. And so here we see that we have mathematically we have a deviation of 0.04 of a degree in the transition, which is, in my opinion, almost nothing. And then here too, calculate that guy. Mathematically here we're seeing 0.05 of a degree. Now, so mathematically this is not a perfect transition, but does that matter? Because if you throw the zebra stripes on here, you'll see that through between this surface, and this surface, like the zebra stripes, run through there absolutely beautifully, and they, you can't see, supposedly there's like a mathematical imperfection here, and it's very difficult to pick that up. And in my opinion, the manufacturing process is completely going to wipe that out. So, I built this with, a bunch of like geometry 3D features that are here in the feature tree. They have other features, and I'll make a couple other videos as time permits. One of the other ones that I really enjoy is like the conic surface, the fence surface. There's a whole bunch of other stuff in here. So, as I come across situations where I resolve geometry using some of these guys as tools instead of like regular SolidWorks tools. I'll make a little video of it and show you. And we got that same like nice highlight traveling through the part. You have this like nice break here at the top. The highlight travels, and here you can start to see that the highlight is blending into the curvature continuous faces into nothing. So there you have it. Hope you enjoyed it, and I hope you learned something.